Hey, you guys are still...
We're good.
Are you good?
Yeah.
You squared away?
We're good.
Well, thank you so much for coming to Tool Drop 2. This is, we did Tool Drop 1 last year, and it was a ton of fun. This is the talk where there is no slides of any kind. Actually, that's not true. There's one slide, and you're looking at it. So, this talk is all demo, so, it's we're gluttons for punishment. So, all we're doing in this talk is we're releasing tools that we've written as penetration testers over the last year. And you'll find that the common theme for a lot of these things is basically we got sick of doing a particular task, and so we automated it, and the goal really is to make our lives easier, and these are tools that we use during our engagements all the time, and so we're releasing it to the community so you guys can use it as well. Hopefully you enjoy it, hope you find some use out of it, and if, like I said, this is the only thing worth taking a picture of right now. After this, it's all just us typing. So if you have questions, by all means, shout out your questions. I don't know that we're just really going to have time, maybe we will, but otherwise, just come on up at the end and throw us your questions. Otherwise, you can find us on Twitter and get in touch with us that way. So that's it. We're going to get started with our first tool called Spin Up, and I'm going to bring the author up here, Hans Locken, who's actually going to talk us through. We did a movie for this particular tool instead of actually doing a live demo just because of heavy reliance on the internet. So turn that over to Hans. Hans, I will get the movie.
All right, so as Jason mentioned, when we do pen tests...
No!
Oh, come on.
Unknown.
Are you kidding me?
Did you test it?
Yes!
Try turning it off and on.
Hold on. VLC, everyone. VLC. All right.
Yeah. All right.
Oh my God.
All right, so when we do our pen tests, oftentimes we'll be running our tools from Amazon Cloud just because we don't want to burn our own private IP space. And we found ourselves, every time we want to do an engagement or stand up a new listener, it would take about an hour or 40 minutes to provision the system, get all the dependencies installed and so forth. So we figured we can automate this, right? That's the whole idea of the cloud, is to be flexible and agile. So what we did here is we got a tool called Spin Up, and from one command line, we can fire an Empire instance up on the cloud go ahead and hit start. And we have a few switches here. We won't go over every single one of them, but you can choose different types of systems you want to, or applications you want to provision. So for example, Metasploit, you can do Pen Tester's Framework, you can do Empire, or if you just want, you can do just a plain system and it'll fire a shell for you back so you can interact with it. So what we're going to do is we're just going to go ahead and run it. We're going to say we want an Empire instance, and we're going to say what port we want it to listen on. So what's really cool is that we're interacting with Amazon's API.
Everyone relax.
We're presumably interacting with Amazon's API right now.
No, really.
And what we're doing is we're going to go ahead and fire it up. And as we're firing up, we say, okay, port 443, we want to not only set up a listener on Empire on that port, we're also going to provision the firewall rules to allow that traffic all the way through. So you don't have to go and manually do this to the web UI, it's just all one command to do it. We also are fast forwarding here, take about 4 minutes to actually fire up the image itself, but now we're going through and downloading the dependencies and installing them on the system. There's a lot of dependencies when it comes to different systems, especially Metasploit. You gotta compile some things from source and blah, 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 so it's a bit of a pain. But in this case here, we're setting up Empire with the RESTful API, so we can actually interact with the system programmably to get the staging key set and so forth. The other thing that this tool can do is if you have, if you're using Amazon's Route 53, which is their DNS service, you can programmably assign a FQDN to your instance. So in this case here, we're assigning it the hostname of potato, and when it fires up here, you'll actually see that a full domain has been assigned to the system with the listener of that name. So on the right-hand side, these are all SSH instances to the system, so we can see that we have a listener that did not assign the DNS name, but I promise you it works. But it's over HTTPS on 443, and then we have the launcher code. If at any point, you ever lose your instance, this is all running in screen, so you can disconnect, run to a different coffee shop, and connect back up. It's all going to listen on there. Yep, that's it. Code's up on GitHub, so if you have any problems, submit an issue.
Thanks, Hans. Next up is Scott Berner. He's going to talk to us about Over Toolkit.
Alright, so this is a PowerShell module, and
what happened here is we found, about February of this year, someone who's actually speaking at this conference, Nick Landers, had talked about a malicious OA rule attack that would allow you to sync a rule to someone's thick client of Outlook, and when that rule synced, it would execute a binary, and then that would give you command and control of the machine. So I was like, that's amazing. I set it up. It was pretty manual, and I was like, I want to automate this. So I started off hammering out some PowerShell, and I came to the point, that was the whole point of this. It ends up that it's not possible through PowerShell. So I have a tool, and it uses an API provided by Microsoft, which, once again, thanks Microsoft, this is a wonderful API, that interacts with something called the Exchange Web Service. Now, how many of you guys are familiar with Exchange? Like, are there any Exchange admins? Okay. So Exchange has a web service that is published publicly by default. And I don't know exactly what the impetus was on their end to do this, but it allows you functionality to people's mailboxes. So you can send mail, get mail, interact with all the features that Exchange offers, except for client-side Outlook rules. So what happens is, I was doing penetration testing. A lot of times on an external pen test, one of the things that I will frequently look for is A, credentials, and B, I'm looking for single-factor endpoints. So one of the great things is the OA interface, which is also part of Exchange, offers the opportunity to get at these things. So if you're on a pen test and you start enumerating the external perimeter and you see this, you can start to get very happy. So one of the good things about Outlook Web App is it's also attached to Active Directory. So most environments are very heavily Windows focused. Active Directory is the center of all authentication within the Windows environment, and this ties right to that. So, and 99 times out of 100, this is single factor if they're exposing it to the internet. So what you're going to do is you'll download the toolkit from GitHub, and you go in here and you can look at what you got. You get a README. The PowerShell module has a Git help feature, so if you install this module and you're looking for help, there's examples for all the modules, all the functions within the module. And what you do is you just import the module. You got to type it correctly though. You'll get a little warning because I used verbs that PowerShell doesn't like steal and brew. So there's functions that are exposed here. Once you import this module does have a dependency. So the dependency is that you need to install the Microsoft EWS SDK. And that just gives you a DLL that they use that kind of abstracts all the web service calls to that Exchange web service that we're talking about. So if you just do git command, maybe not. No. Anyways, we'll just skip that. So one of the first things you can do here is, one of the functions is called scan EWS, and what this does is, it's something that I have done manually many times, is just a DNS group for subdomains within a certain top-level domain. So you just pass it a top-level domain. In this case, we're going to use EvilCorp. We set up a small test domain here with a DC and Exchange, and that's why my fingers are crossed for this demo, because it's just running all on this laptop. And so, yeah, fingers crossed. But what this will do is it will scan, it'll brute force various subdomains that are very common to have OA or Exchange Web Service on them. Let me see here. Once it finds a possible link to the Exchange Web Service, it just prints that to the screen. So you'll see this very commonly as Exchange or OA or webmail. If you do pass the verbose function here, you can see all the domains that it's actually testing with. Now, one caveat here is very frequently, you'll get some environment that's like one-off, and they'll be like, who knows, maybe it says Lotus Notes, but it's actually Exchange. I do really recommend that you manually look for this stuff, and you can definitely use it. If you find that Exchange Web Service at any other path, you can use that URL later in the tool as well. So once you've detected Exchange Web Service, I had talked briefly earlier about the malicious Outlook rule. That functionality isn't yet automated within this toolkit, but you can scan for something called MAPI. And MAPI is the interface that's open for this that will allow that client-side rule to sync. Unfortunately, it's a pretty complicated protocol, and when I got into this, like I was saying, it wasn't abstracted within the PowerShell EWS API. But another person has automated that in a tool called Ruler, which I highly recommend you guys check out. All right, so here's a surprise. Microsoft actually uses their own stuff. So MAPI is exposed for Microsoft. Again, you can pass this verbose tag. You can see it's just doing a quick DNS root. And then once it finds possible places where that might exist, it just does a web request. And if it gets the right response code, it prints that off the screen. So once you've detected that an organization has EWS exposed, the next piece that you're going to want to do is you're going to want to brute force this. And one of the things I really like about this is that since it's tied to AD, you're going to get AD creds, and it's very commonly single factor. I've actually seen companies that have OLA, the OLA web access piece, be two-factor, but the web service for Exchange is actually still single factor, which is really nice. So what you're going to do, see if I had this stored, so I'll type it. Awesome. So there's a function exposed here called brute EWS, and you're going to pass this all these different parameters. You can see the first one is the password. I highly recommend just doing like season, year.
Can you cancel that if I get error questions are installed because it's really low? There you go.
Like this?
There you go.
Is that better?
Yeah, it's amazing.
So you can see the parameters here. The first one's just the password. The second one is a target list. That's just a single text file with users in it. The next one is the Exchange version. Now, the Exchange version, you're going to have to get that prior to doing this. It's actually pretty simple to get. If you find the OLA page, go there, view source, and then the Exchange version will be in the JavaScript that they're loading in, just the exact patched version. So you can just Google that and you'll find the Exchange version. Pass it the EWS path and the domain, and enter, cross your fingers. Hope this works. Yes. All right, it worked. I'm surprised. So this is actually a multi-threaded PowerShell brute forcer for this EWS service. And what you see here is there's just a list of users. We tried one password per user, and then you can see it's successfully authenticated with T-Code at EvilCorp, spring 2016. What I do at that point is I'm using my Exchange service to make a call and see how many unread emails that person has, just to verify that it's actually working. Now, what we're talking about, here, I'm going to clear it again. So one of the things that this toolkit does is it creates an object. A PowerShell object, if you're familiar with PowerShell, is a nice data structure, and it's one of the things that makes PowerShell really nice. And this object is actually the interface to that DLL that Microsoft made for EWS. So if you initialize this object, you can do it outside the toolkit just using the OTK init function. And you can see that there's a ton of methods here. Now, this toolkit didn't abstract every single one of these methods to perform all these options on EWS, but you can see there's things in here like search mailboxes. One of the things that I'm working on in a version after this one is searching people's Outlook notes across the enterprise. I don't know how many people do penetration testing, but it's very common that people will put passwords in their Outlook notes. It's horrible. So many system admins do that, and yeah, it's awful. But I'm making a way to scan that so you can just don't have to manually go into each mailbox. And that's one of those things that's kind of a recurring theme. I was finding myself manually going through and doing this, and so now it's automated. So once you have creds, the first thing you do when you get creds to email is you're going to want to go check it out, right? So the automated pillaging piece here, one of the best things about EWS is that it exposes the global address book. How many of you guys are familiar with the global address book? All right. So I found myself, every time doing this, I'd have to like fire up Burp, go through and like scroll through the whole address book, and then like take out the text of everyone's email and like grep through it or whatever. And I did that a couple times. Like, this is awful. I need to automate this. So what you can do, you can take the exchange object that we created earlier. Yep. Where is it? There it is. All right. So one of the other functions that I exposed is just called steal Gale. What steal Gale does? So this function was not exposed to EWS. There's not a way to just say, give me all the people in the global address book. But what you can do is search for a specific name. And what you'll do is you'll search for like one character. I found that you can put in like A, you search for one character, you get like 100, max of 100 results. So what steal Gale does is it recursively goes through and it'll go for every letter of the alphabet. And then if the returned amount is more than 100, it'll append another letter to that. So you're going to search A, and then, you know, it just recurses. It only goes 3 layers deep, but I have stolen Gales that have been multiple thousands. So I don't know about hundreds of thousands, so I haven't tested that yet, but multiple thousands, this works. Now, one of the things that's great about this is it returns it as an object as well. So people familiar with PowerShell know all the power that there's an object here. You could pass it to in the pipeline to other things as well. This is also a standalone function, so you could do steal Gale. If you already know a password, you could just do that without making the object. Just run like this. Now this one, so if you're familiar with PowerShell, one of my favorite commandlets is the out grid view. So you help get that object out grid view. You have all your users here. If you're trying to target someone specific or fish people, you'll have all that information there. One of the next things I do here is once I get the global address book, I take all the users that I got, because I probably only got a subset of users from public information gathering. I'll take all the users and go back and root again and get most likely more creds. So the other thing is once you've gotten credentials, you know, every penetration tester is after, you know, shell access to the internal network. Go back and see if there's, you know, single factor other endpoints like Citrix or VPN. Use those creds there, and if it's single factor, you'll probably get it. All right, I think that's it.
Questions? Questions for Scott?
Sweet. You already blocked out accounts?
Yes. So one of the things one of my colleagues has put in a bunch of code to this. I was really disappointed I couldn't get it all working for the demo here. But what we did is we added a SQLite database, and what it does is it stores credentials, things like that, stores information that you might need to do this kind of operation. But it also allows you to schedule the groups. So a lot of times we'll know that people's lockout window is 30 minutes. So you schedule the group to go every 40 minutes, and then you're golden. And it gets a list, and then we're going to have notifications and things like that. So good things to come. I actually mentioned that I was going to talk about things we're making next. That was a good segue. So yes, I lock out accounts, but eventually we're not going to. Yeah, so the dependencies you need to, I recommend PowerShell version 5 because that's what I've coded it on. And since it's an attack tool, I would say just get the latest PowerShell. The other thing is you need to install Microsoft Exchange Web Service SDK. So there's just an MSI that they have. Thank you.
Cool stuff. Well, we got one last tool to show you. What's that? Picky. You want to see? Last tool we're going to show you is a tool called Lucky Strike. Lucky Strike is a utility that was built really out of necessity. We, as penetration testers, we do social engineering, and one of the tasks that we do frequently when we have to do social engineering is we send an Office document that has a malicious macro. If you're a pen tester, you are very, very familiar with this routine. You fire up Unicorn, or you fire up some utility that's going to give you like a PowerShell-based macro or an exe-based macro, and you have to open Excel or you open Word, you paste all the macro code in, you do a bunch of testing, it might work, it might not, it might get picked up by AV, it might not. We got sick of this, and so this started as my brainchild, I guess, when I was like, you know what, I'm tired of doing this task over and over and over again, so I want to automate something that's going to take a Unicorn output or an Empire Stager output and just make an an Excel document. We have one Excel document that I'll actually show you. It's one of our favorite templates. It's just a calendar that says you have to enable content, and we send it to users, and it's like we get shells all the time with that one. And so it's just one of those things where we got sick of doing the same repeated task over and over again, and so I was like, all right, that's where this is going to start. And then the team started chiming in, saying, well, wait a second, what if we want to use that payload? Is there a way that we can save the payload and reuse it and things like that? And so that morphed it into a whole something else. And
It's a framework.
it's not a framework. No. It's an extensible modular framework that's based on Node.js. It's not PowerShell, because PowerShell's better. So anyway, Lucky Strike is currently available on GitHub. The only thing you have to do in order to install it is run this little IEX command right here. Before you panic, we'll actually talk through what the install.ps1 does. So install.ps1, all this is going to do on the back end is it's going to download and import the one dependency that Lucky Strike has, which is the PS SQLite module. What happens on the back end, and it goes through a whole ton of table creation, because the way that making macros works is if you're familiar with making malicious macros, you obviously have code dependencies and code block dependencies, just like you do for making any other kind of macro. But in this case, Lucky Strike stores all of the macro dependencies in the database as code blocks. And you can see, for example, this is where we add our own personal obfuscation that's designed to bypass AV. If that's what you're worried about, having these payloads get picked up by AV, well, yes, they can get picked up. In all the testing that I've done, only 2 of the payloads have gotten picked up, and they get picked up by Avast, and they get picked up by Clam AV. So, anyways, because everyone uses that. So, let's actually show you. Let's pick it up from the start and actually dive into this. So, if at any point you have questions or you can't see, just let me know. I'm going to be walking through a lot of different attacks. So this is the output that you'll see after running the installation. You're only going to see it's going to create a Lucky Strike directory for you, and it's going to only have 2 files in there, the ls.db, which is the SQLite backend database, and then the script itself. The script itself is it's a menu-driven script. And you're going to have to forgive me because I've been in these menus for months now, so if I go too fast, just tell me to slow down, and we can certainly do that. So if you can't see in the back, I apologize. I don't know. I don't know how much I can share this. What's that? Resize the window. Let's try resizing the window. Come on, listen to me. Maybe like that and like that. Yeah, a little bit better? Okay. So, terminology. Let's talk terminology real quick so you don't get lost in the terms. There are 3 different terms you're going to hear me use repeatedly. The first term is payload. Payload is something that actually is what you want to be fired on your target. This is made specifically for phishing. So, and you create your malicious macro, it outputs the XLS, and then you send it to your target, target clicks enable content, and then it does whatever you want it to do that's configured in the payload. The second terminology, or the second term I'm going to use is catalog. Catalog is basically the word that I use for the database. So you're going to take a payload, you're going to add a payload to the catalog, and then that payload is going to be available in the catalog for selecting and making your malicious macros. So the whole point of this is reusability. Like I said, if I have my Empire, one of my Empire servers, it's generally going to have the same staging key, it's generally going to have the same IP address, and I'm going to be using the same launcher code over and over and over again. And the whole goal of this was to simply be able to store those payloads into a database so that I can grab them and reuse them anytime I want. So the last thing is simply infection types. We'll get into infection types in just a second. So before we do anything, we need to actually get a payload into the catalog. We're going to start simple, and then we're going to get a little bit more complex. So the first payload that we're going to add, and once again, stop me if you can't see, the first payload that we're going to add is we're going to add just cal. Okay. I have a few fields here that are optional, really for record keeping purposes. The target IP, the target port, and then description. We're just going to call this cal.exe, and now to choose a payload type. Lucky Strike supports 3 payload types. The first one is a simple shell command. This is going to be useful for something like your Empire stager. If you just pipe that out directly to your launcher code, it's going to be useful for firing any shell command that you want to fire on the system. You do have to be a little careful about escaping. I try and do as much of that for you as I can, but it's more of an art than a science. So we're going to choose a shell command, and then all we're going to do, calc.exe. This is the actual payload that we're going to run. So payload's now been added to the catalog. Okay. So if we actually look at the catalog, now you see calc. If I close Lucky Strike and reopen it, and we go back to the catalog, and you see calc is still there. So once again, point of this, reusability. Okay, I want everything to be stored so I can use it over and over and over again. So now that we have a payload in the catalog, well, let's create a new file, right? So I go to the file menu and I just want to generate a new file. Right now, Lucky Strike only supports .xls, which is 97/2003. Word documents will come eventually, but it's way easier to stash payloads in Excel than is Word, so that's where I started. So if we just generate a new XLS right now, well, you're going to see you have to add a payload first. Just because you have a payload in the catalog, it's not going to take all of your payloads and throw them in there, because the goal of this is to eventually get lots and lots of payloads in the catalog. So first, you have to select a payload that you want. So we're going to choose calc. And now you get to choose the infection type. Every payload type, whether it's a shell command, PowerShell script, or an exe, has multiple infection types. A shell command is basically just run shell. We'll dive into the macro code in case there's questions. The metadata infection type will actually take that command, shove it into the metadata, and then use the macro to call the metadata and fire your command. So the infection types is really the delivery mechanism, and this is where all the obfuscation, things like that are built in to try and avoid AV. So in this case, we're just going to choose simple shell command, back up, and now we can actually create a file. So we're going to generate a new XLS. Okay, so success, file saved to Caesar's attack or desktop Lucky Strike. It creates a payload directory for you, and then just, random name. So let's actually have a look at that. Lucky Strike, payloads, infected. Okay, blank spreadsheet, open that up, enable content, there's calc, now let's see how it's done. This is the simplest of attack methods. So the first one, it creates auto open, gives you a bogus function name, really no obfuscation except for this line. So when I was doing testing, initially everything was getting picked up by Windows Defender, and I noticed that all you have to do in order to fix Windows Defender so it doesn't catch anything is just to do a concatenation here on wscript shell and solve that problem. So anyway, thanks Microsoft, sweet. So that's like the simplest of examples. Let's get into something a little more complicated. Okay, let's put some more stuff into the catalog. So let's add PS run calc. Okay, this is a PowerShell script. Let me actually grab, where is it? Let's grab my pad. And run calc, yeah. Is that right? Cool. So we got run calc in there now. All run calc is that's basically just this. Start process calc. The point being is that we're going to demonstrate a PowerShell-based attack. Okay? So PowerShell-based attack, very important, one note that I need to mention is that any PS1 scripts that you import need to be non-encoded. Lucky Strike will encode as necessary based on the infection type that you choose. So if you're going to import a PowerShell script into the catalog, it needs to be completely unencoded. So now that we have that in there, let's select that payload, PS run calc, and now we have three infection types of PowerShell scripts. The first one, cell embed, that's basically just your go-to. What happens in that particular attack is that the PS1 gets base64 encoded and then jammed into cells and then reconcatenated, rebuilt prior to running. The second one, cell embed non-base64, is exactly what you would think it is. The entire payload is shoved into a cell in plain text. If there are things like if you have I don't know, some heuristics that's picking or tripping on base64 encoding or something like that, that's a good attack for that. And then the last one is just purely evil, and we'll talk about that in just a second. So we add the cell embed. Yeah, show selected payloads. Yeah, there's got to be above there. Did I do that? Yeah, I did. And then let's create. Hopefully this worked. At least I think I added it. Payloads, effective, VG something. And we got calc. So let's have a look at this macro. This gets a little more complicated. So in this case, going back to the install script, everything is jammed into the database in terms of code blocks. And the reason why I did this is because there are some payloads that are dependent on the same code blocks. Like I might have 5 different payloads, and each one of those payloads is dependent on the same code block, so I want reusability. I didn't want to just duplicate function methods and give them different random names because that's just sloppy, and let's not do that. So insert into code blocks. The code blocks table is what contains all of the macro code, and eventually it's going to contain PowerShell code. So going back there, this is the function that actually just concatenates everything, start and end. Random name does exactly what you think it does. And then down here, I hope you guys can see this. This is the obfuscated PowerShell command. Basically, it's just PowerShell dash no op dash noni dash window style hidden, and then here's the actual dash enc. You grab that, fire it, you get calc. That's exactly how that attack works. So the way that Lucky Strike knows how to, or the way that the macro knows where the payloads are stored, this is actually kind of important because if you notice, when you actually open that spreadsheet, there's nothing there. It's not like I'm jamming the payload in A1. Well, what ends up happening is that when the payload gets added, when you select the payload to use, Lucky Strike creates a legend string. And so this is the start row, this is the end row, and this is the start column of where the payload is actually hiding. And I do this like starting way over in column 100, starting down on row 50,000, so users aren't going to, it's not going to see it. So even if you're using a template XLS file, chances are you're not going to override anything. So that's that attack. Let's do. This is gonna be fun now. Before it was just boring, right? No one cares about a standard embedded attack. So let's select that payload via strong cal, and then let's do the encrypted. Let's do the encrypted attack. So when you do the encrypted attack, this attack was designed specifically for sandbox evasion. So I don't know if this ever happened to you, but you create your fancy shiny new payload, you send it off to your customer, you get a bunch of shells, and 2 hours later you get a shell from John at John's PC. And I'm like, what the heck is going on? The first time this happened to me, I was like, well, who's John? So I'm like, okay, let's interact. And the shell died, and I was like, well, what is this? Well, it took me a while to figure out this is actually VirusTotal. Or some other AV signature-based, company that is going to take your payload, it's going to run it to determine if it's malware, and it sees the shell going back and forth, and now your payload is flagged as being malicious, and you can't use it. So that's irritating, right? I want to use my payloads. So what the encrypted attack does is you should know the target that you want to phish. So let's say I want to phish a company. I want to phish Bob at evilcorp.com. Okay, now I know what that domain is. You've done your OSINT, you've done your recon. You know what the domain is. So the way that this particular attack works is that once the macro lands and it gets fired, there's a function there that will call out to Active Directory, retrieve the user's email address from Active Directory, the mail attribute, split off the end tag, which should match what you put in, and then if that works, it'll be decrypted and the payload will run. Let's actually walk through this. evilcorp.com. Okay? So we have a payload added. Let's create a file. And that is called GPU something something. Okay, so we open up our new file and we can enable content. Well, it's going to spin and spin and spin and spin and spin, and then you're going to see an error. And the reason why you're going to see an error is because my machine is not joined to the domain. So this is actually simulating what would happen if I were an AV vendor that was actually trying to do analysis on this file. You're going to see something like the specified domain either does not exist or cannot be contacted, and then it stops, it dies. So if we actually go into this, this is the function, the EM function right here, is what retrieves the email address. That string that I put into Lucky Strike, evilcorp.com, is the encryption key. And what happens is that Lucky Strike will RC4 encrypt the payload with that key. And then once the macro fires, down here, a bunch of other naughtiness, what happens is that the macro code right here will call out to Active Directory, call this function, EM. It will get the email address, and then right here is the call to actually do the decryption. It will decrypt, it will attempt to decrypt the payload using the SMTP domain of the user. So you are targeting a domain user with the knowledge that they probably have read access to Active Directory, they're an authenticated user, they're going to be able to go out and retrieve the mail attribute, which is what this is calling, which is what AD uses by default, split off the string, and hopefully using the same domain that you put in, it's going to attempt to decrypt. So, in this case, I'm just going to kind of hijack this, evilcorp.com, because that's what that function would have returned. Everyone following me so far? All right, good. Yeah. And then, dear God, fingers crossed, run that macro, and there's Cal. That's the encrypted attack. Can't wait to use that one on our next customer. Let's get into some maxis. Oops. Let's add payloads to the catalog. Let's add putty. Just because we love putty. DerbyCon, grab my payloads. Putty.exe. What LuckyStrike does is LuckyStrike will actually take the executable, convert it to a byte array, basic 64 encode the byte array, and then stick that in the SQLite database. Okay? So XEs are also stored. Now that we have that, oops, let's select that payload. And now you have a different set of infection methods. You have the certutil infection method, which is based on Matt Graber's outstanding work, where he found that you can actually take a base 64 encoded file, use the Microsoft signed certutil.exe, decode that file to a binary, and then run the binary. We'll actually demonstrate that now. Save to disk. It does exactly what you think it does. It saves the exe to disk and then fires the exe. And then reflected PE. We'll demonstrate that one in a second. So certutil. We got that, and then let's actually generate a new file. How am I doing my time? Straight payloads D0 something something. Okay. Certutil generally takes a while to recompile the file. The file gets recompiled, putty gets fired. Digging into that. This is the actual code. Just a little bit of obfuscation here. I don't know many AV vendors that are looking for certificates in their macro. If they are, hats off to them, but really honestly no one does that. So and then here's the obfuscation call to actually run the binary. So in case you're wondering, where are the payloads stored? Well, the payloads are stored in app data running Microsoft admins. It is an exe. Some of you intrepid sysadmins are like, well, I block exes from being fired from app data. Well, I have something for you. Let's actually get rid of these. Okay. How many are familiar with invoke reflected P injection? Anyone? Okay. That is, so what invoke reflected P injection is that is a script that Matt Graber put out as part of PowerSploit. And what it does is it allows you to read in a byte array, and it opens up a section of memory and fires that byte array into a section of memory. Now what's awesome about that is that you can generally fire invoke reflected P injection so long as your executable supports ASLR and dev. You can take that executable and load it directly into memory without ever having to write an executable to disk, which I thought was just totally sexy with Brandon. So we decided to embed that attack. Let's actually have a look at that. Before we do that, let's put something else in the catalog. Everyone see? Still going okay? All right. We're going to add evil.exe to the catalog. This is an executable. Grab this from our little evil.exe. And then let's create that file. All right, so we have our malicious payload. Now, I want you to pay attention to this directory. This is basically where LuckyStrike just drops stuff, okay? Roman Microsoft adds. Now, you saw before that the executable was actually created, a .exe was actually created to that directory and fired. If this goes right, what you're going to see here is not an executable that gets written. You're going to see two text files. And we'll actually talk about those text files in just a second. The minute that you select a reflective PE, did I choose that? Payload added. No, I didn't choose that. That's wrong. Hold on. Select the payload, evil.exe, and then we choose the reflective PE type. There's a bug in there somewhere. Is the executable 64-bit? No, it's not. You need to know your architecture for the executable that you want to fire. Are you a DerbyCon? Yes. I built in just a little switch so you can actually see the payload pop. I took that out in the prod version that's on GitHub. But the reason why I included that is so that way you actually see the executable pop to the screen. Otherwise, it would just be hidden. Okay, so now that we have that payload added, let's create the file. Fingers crossed. And payloads. It's not called KL something. Okay. Once again, let's pay attention to this directory. If everything works, like I said, you'll see two text files get rid of, and then you'll see the executable pop, and then we'll actually talk through this. Oh my gosh, it worked. I'm so excited. So there's the executable, and you see two text files. This first text file is a base64 encoded representation of invoked reflected bead injection. Okay, so, and the second text file is the actual executable, which is base64 encoded. So, like I said, if you're blocking exes from being run from app data, well, I'm writing text files to app data, which is standard operating procedure for Windows. So let's actually shut that down and take a look at what's happening behind the scenes.
Jason, does this need to download anything from the internet?
No. The question was, does it need to download anything from the internet? No, we are embedding payloads into a spreadsheet. Now, the only time that a call would happen to go out to the internet is if your payload uses a stager, or if you're embedding like C2, which obviously is going to be the internet. But the whole point of this is to embed payloads, not just have a download string, unless that's what you want as your payload. So here's all the evilness right here. You can see I tried my best to heavily obfuscate this. But basically what's happening is that we're running PowerShell based on the architecture of the executable, because that's important. And then down here, we're actually, we're writing the text files to app data, and then catting them, we're doing get content to bring those text files back into memory and then fire them out. If you just try to do this all from memory in the macro, well, Excel pukes and it hates you. So had to actually write something to disk. So it's not 100% OffSec safe, but like I said, no executables be written. So that's all great, that's wonderful, but as pen testers, you're going to want shells, and that's what I want. So another main driver behind Lucky Strike was the fact that we wanted to be able to run multiple payloads, embed multiple payloads of multiple infection types into a template XLS. So that's exactly what we're going to do. Let's add two more to the catalog. I have a standard MSF executable. And this is just something that I, used MSF Venom to create. MSF.exe. And then we're going to add, we're going to call this Empire. And then let's put our launcher code in there. Launcher.ps1. Remember, launcher decoded. Okay, so when you do your launcher code, you need to take that base64 string, decode it, and then bring that into Lucky Strike. Okay, so we have both our payloads in there now. Now let's actually select them. I'm going to select the MSF payload, the executable, and we're just going to do a standard save to disk. Unfortunately, payloads that MSF Venom generates do not work with reflective bead injection, at least not yet. And then we're going to take our Empire one, and we're simply going to embed that. Okay. So now I have those payloads selected, and I have a template. Here's a template, standard template. When you click Enable Content, basically just pops a calendar. This is one of our phishing techniques. We embed some naughtiness in there, and then we say, hey, we changed vacation, and everything's been canceled, and we send it 2 weeks before Christmas, and everyone panics, and we get a ton of shells. So,
Merry Christmas.
Merry Christmas, that's right. So, what's interesting about this, the important thing to pay attention to, is that there is already macro code in here. And one of the main drivers behind Lucky Strike is that we wanted to be able to take a template that already had a macro in it and embed our naughtiness into that macro. So, let's do that. We're going to choose from the file option. We're going to update an existing XLS. Enter the path to existing XLS. Make sure nothing is password protected. FYI. Template.xls. Probably going to get a warning here. Do you want to replace this? Yes, we do. And a compatibility checker. Click continue. So now we have our payload. So over here, security is great, so it gets my way. Over here, I have two terminals. One of them has an Empire listener, the other has a Metasploit listener. Heaven help me, hope this works. So we created our payload, infected underscore template, 8z something something. Right. Payloads template. Here's your template. Let's enable content. Magic is happening. Bob is like, oh, I can't get to my calendar. What's happening to my vacation? Metasploit session down here. Empire session up here. Calendar opens. Bob sees nothing. Bob goes about making money because he's in sales. And then we're done. So that was the whole point behind that. Like I said, all the apparently you got a massive bug there. Catalog. All the payloads were still in the catalog. So one of the goals, another goal behind this was you can take that ls.db file, sync it through Git, have the rest of your team pull it down, and everyone has access to the same catalog. So that concludes that demo. Question in the back, yes, sir?
Thought about adding the templates to the catalog, so you
Dang it. So the question was, can you add a template to the catalog? That is the very next feature that I'm going to release. I was like rage coding this last night, and I'm like, I can do it, I can do it. No, I couldn't do it. So what I did do though is in the just to satisfy, I have a table already created in the database called templates. So everything is already prepped for it. It's just not built yet. So yes, sir, right here.
how big are the spreadsheets that you're creating?
Good question. It's all going to depend on your payload. If you embed a massive executable, you're going to get a massive spreadsheet. So if you embed a PowerShell script, it's going to be small. Yes, sir?
Does FlexPE clean up the text files?
Really good question. No, I'm not doing any cleanup because I'm lazy like that. I thought about melting all this away, and that's definitely something for future improvement, but right now there's no cleanup that's being done. So that's it. Thanks so much.
So you're going to go to the track tour?
So I think it's 99, yeah. What did you do? What was it? So I used, and I forgot that demo was 98. Yeah. You get 98 and you just what's happening? That's my stuff! I wrote that! That's awesome! Right, exactly. Awesome, nice to meet you. So, a really good question. I'm going to defer you to Hans. Long story short, they are just hard as long as you fill out the form. You have to fill out the testing form. You want to know how well things are using this stuff for an audience.
Oh, yeah. Yeah, so
Shine and rise. Like your bow tie. Quit chewing. Huh? What are you quit chewing?
You want it on solid? Is that solid now?
No. I like that. Is it just EL wire? That's all it is. So you bought it like that, or? So, I asked three of y'all, are y'all going to be sitting down or walking around?
I like build by static. If I can sit, I'm going to sit till my turn. My turn's at the end. I'm like to clean up through it.
Yeah.
Makes the whole talk fun. So
Three of y'all.
shitless is pretty much there.
What's that?
So
on your
Yeah, I just want to put the microphone back. The next speaker.
I'm going to probably do a split.
Yeah, because they have my slides, they have everything. That's it. Break it up.
Do y'all need a lot of real estate for your slideshow,
No.
or do you think we should do this?
More on the slide, less on us.
Okay.
At least till the end. You might switch it actually at the end when people. I don't know. We'll find out. I just kind of hope my co-conspirators show.
Right.
Yeah. You get on that ship. Oh, maybe we can't find that little button. There. Am I flashing now? Yes, there it is. There. Not flashing everyone's what?
Now it's on.
Off? Or steady out? So there. Not flashing everyone slowly. And here's a fast flash. Now it should be off. And on solid. Too much counting involved in remembering track of where it is. Hey, where's my co-conspirators? Doing this whole talk without the slides will not be as much fun. There's one down. Although it's going to be sad if I don't have Bill. Oh, what color do you like?
I'll go back and remember it, yeah.
I think she was. What did Amanda say? Amanda either said that she liked or didn't like pink. So I assume that whether she likes pink or doesn't like pink, I could probably just hand her a pink one and it's considered a messing with, and I win on both accounts, right? Okay, where'd Jeremy go?
Stuff they do to known and friendly and stuff. And one thing they do is page action. Take all your page code and then take all the content out of the structure and take the structure and see that, compare that to the structure of the other pages. And likely to put things together the same sort of way over and over. You know, you did this, and there's still a chance that this is, yeah, so it's a cool trick. Yeah. Oh, yeah.